All right. So basically, if you have a log equation, you can change it to an exponential equation. And then sometimes it'll be easier to solve that way or just kind of see what's going on. So number one, it says solve for x. So apply the definition. Okay, so the base of the log becomes the base of the exponential. So this is the same as 8 to the b is this part, 2, right? Double check myself, 8b, and it's equal to c. All right, so now it's a lot easier to see what x is, right? What is x? Yeah, x is 64 by the definition. So we didn't have to really use any fancy properties. We just used the definition to change a log back into an exponential, and we could see the answer. We just applied a formula, really. Nothing crazy, right? So check out this one. Let's follow along with their answer. They had solve for x, log base x of 9 equal to 1/2. So what is the x? Well, change it to an exponential, and they did. So check it out. The x is still the base. The equal to is the power. So now we're going to solve this guy. Now you can kind of look at it and see the answer, right? Square root of what is 9? Square root of 81 is 9, right? But you can solve for it by squaring both sides, canceling your root, right? Square root. Because remember, 1/2 power is a square root. So squaring it should cancel it. And this is why. So then you get just an x. 9 squared is 81. Are there any questions on what they did here? Not too bad, right? Let's move on to something else. This guy, I say we use this property. Yeah, I don't like the way they do it. Well, yeah, this is how we're gonna do it. Let me show you on paper. Log base 2 of negative 5x plus 10 is equal to 2. So what I recommend is using this property we said whenever you have, let's say, a base A raised to a log of the same base as your power, then they cancel, leaving you at the x. Or if you have, uh, what's it called? So I'm gonna write the properties we're gonna need right there. What's the other one? Oh yeah, log base A of x to the of A to the x. Then those cancel, leaving you with an x because they are inverses of each other. Also, we said if A is equal to B, then A to the x is equal to B to the x. Hold on, sorry. That is fake math. That is the same as saying x to the A equal to x to the B. Yeah, there we go. So knowing these properties, and remember I wrote them all down earlier and I sent you a PDF, I want to purposely cancel the log. So I want this to happen. See how if I have a base A here matching up, the log will be gone and I can solve for x. So basically I have a log, I need to cancel it. The inverse of a log is the exponential. So the inverse of this log base 2 would be 2 to the x. So what you do is introduce a 2 as your base purposely on both sides, like this. So basically, if I have an equation, I can bring any base that I want. I'm choosing 2 on purpose so these can cancel. You see what I'm doing, or why I brought in the 2? I chose the 2, so this would happen. That's why you cancel logs. Any questions about that? You could think of it in terms of the definition, but I think this makes more sense. I just bring in a base, cancel my log, solve for x. Subtract the 10 on both sides, right? Divide by -5. You guys cool on 3? Whenever you introduce this base of your choosing, make sure that There's nothing in front of your log. So let's do another one. It's number 4. -7 log base 5 of 4x equals -14. Okay. So first thing is to get rid of that -7 and then introduce a base. So what base do I need to introduce to cancel the log base 5? Right, they need to match. So if you have a log base 5, you introduce a base 5 to cancel it. Okay. So bring in the 5 as your base on purpose on both sides. Now these will cancel, leaving you with 4x equal to 25. So now I have no more log and you can just solve for x. Does that make sense? Okay. All right, so that's number 4. All right, let's do one that's a little different, but not too different. So this is called the natural log. When you see ln like this, 4 ln 5x, all that really means is this. It's just a special base. So this is on your calculator. It's called the natural log. So the natural log and the common log are the ones that are on your calculator. No, nothing else is. But it's basically just saying log base e. E is a special number like pi. It repeats forever, 2.17 something something forever. It's an important number, but we're not going to get into the weeds on why. Uh, just treat it like you would pi, okay? Special number. So if you have an ln, you're going to have to introduce an e to cancel. But first, we got to get rid of that 4 before we do anything. Divide both sides by 4. Then we got -1. Now introduce your e, because that's the base that I need to cancel ln, the natural log. These cancel. Now I have 5x equal to e. Divide both sides by 5. amount of space. So we get x equal to 1 over 5e, whatever that is. Some decimal number. Because you have a negative exponent, you bring it down on the bottom. But e is just a number. I think they actually punched into the calculator instead of doing this. They just said it was this. So if they said rounding, once you got to here, just punch this into your calculator. This is the exact answer, but this is the decimal. Is there any questions on number 5? Okay. Okay. So E is 2.71828, also called Euler's number or the natural number, which is the base for a very useful base. So whenever they use it, we use it so much that it was better to shorthand and shorten it to ln x. So ln x just means this, the natural log. All right, let's move on to something else then. Hmm, That was number 5. Yeah, the base doesn't matter. Um, the work will be the same. Like if it was log base 2, then I would have brought twos right here, right? Like we did well, actually this one was 5. So I brought in some fives to help me out. Cancel it. Here we had natural log, which is an e, so I brought in the e's, which canceled it. Solve for x. E is just some number. Who cares? It is the same as the number 4. It's a special number, but that's all it is. Still a number. Let's move on to I think it's number 6. Yeah. So this will take some practice and some time. I don't expect y'all to be pros at this right this second. If you feel confused, then we just need some practice because we just started talking about the properties. Okay, but don't feel scared or stressed. You got to practice it. Take your time. So let's check this one out. So I can't do my trick to cancel the logs because they're all separate. So you're going to want to combine them first. But there's logs on separate sides. So let me see what we could do. And then I think the only choice is to subtract this guy over here and combine those logs into one. Because you can't cancel logs until they're all combined into a single log. So I'm going to subtract that log over here. They're both base 2. So since I have subtraction, what can I do with these guys? We combine them into a quotient, right? Now that it's a single log, then we can cancel this log and solve for x. Right now, we really can't. So introduce 2 on purpose as your base. So now this becomes your powers, just like before. These will cancel. Now we have this weirdness here. So now we can solve for x. You guys still with me up to this point? Okay, so after that, we're just doing algebra. The log stuff is done. So x minus 4 is on the bottom. I need to solve for x, and it's on both parts. So what I recommend is multiply both sides by x minus 4. That will cancel. Get to here. Distribute your 4. Combine your x's, get them all on one side. Yeah, pretty much. I chose this denominator because it was down here. So if I multiply on both sides, I can get rid of it. You could think of it as cross multiplication, but I don't like using that because then people get confused. So this is a legit algebra step. Cancel your fractions. How do we cancel? Multiply both sides by LCD. No more fractions. Solve for x. Subtract your 4 over here. That gives me 3, negative 3x. Add the 7 over. Divide by negative 3. Yeah, 3. They do want us to check. Let me show you. I don't think I've been checking this. You gotta plug it into the original and see if it works. I'll check it over here, just so it's not too go to another page. So I'm plugging in three and seeing if it is a solution. So whenever you introduce the base like that, sometimes you get weird answers and you gotta check it. But notice what's gonna happen. You can't have any negatives inside logarithms. So if you saw the definition of logs video, can't do this. It's outside the domain. So x equals 3 is not a solution, even though we did all that work. There is no solution to this question. So you would do all this work just to say this equation does not have a solution. Are there any questions on the log part or the testing part or this algebra part? Alrighty. Move on to something else then. This one, let me show you the work. It's the same question, same thing we just did, except it's ln. So save a little time. Let's follow along with the solution. All right, so first step, combine all the logs on both sides into a single log. So they combine these two using the product rule, right? And then they multiply the two, getting us this. Now, if you introduce the e like we did earlier, these will cancel, leaving you with this here. So, solve for x, right? Subtract this, solve for x, and you're going to get 16. Once you have that, plug it into the original stuff. Plug it into this one. So, 16 goes there. That 2 was already there. Plug in the 16 minus 8, you get this. Combine them into a single log and you get this. So now they are equal, right? We have equality on both sides. So that means since we have a true statement, it is a solution. So you can say, yeah, x is 16. Do you see the main idea of what we're doing, right? Combine the logs, cancel the logs, solve for x. Once you have x, test it. You guys okay? All right, so we just finished log equations. Now we're gonna do exponential equations. Okay. So before we were introducing a base to cancel the log. Now we're going to introduce a log unless we can make the bases the same. Can I rewrite this as a power of 2? What number was this, by the way? There's two ways to solve this. Introduce a logarithm, bring down the powers, or try to match the bases. 32 is a power of 2, right? That's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So do you agree that this is 2 to the 5th equal to 2 to the 4th? Is that okay? So if they match, then you can set the powers equal to each other. if you have a power raised to another power, before I do that, I want you to see that this is the same as 4 times negative x minus 2. So now you can just set these equal to each other. So we'll write a property here. I think I wrote it earlier, actually. A to the x equal to a to the y implies that x is equal to y. And we can go both directions. So if these are the same, you jump to here. Distribute your 4. Now solve for x. Are there any questions on number 8? Add your 8 over, that'll be 13. Let's skip some minor steps there. So most of the time, you're not going to be able to match the base. So I prefer we introduce logs on purpose. Like an 8 will never become a 7. So introduce a log of your choosing. I'm going to choose ln just because I like it. Now I can bring powers down using the power property. The whole reason we practiced those was to bring the powers down. Distribute your ln onto both, giving us this. ln 8, ln 7 are just some decimal numbers, so don't let it freak you out. It's just some numbers. I'm trying to solve for x. This is pretend this is like a 5x plus some number equal to 2 or something. You would divide this out, right? Once it's isolated. So move this guy over there and divide by ln 8. So subtract the 3 ln 8, then divide both sides by this. So x is equal to this guy. So at this point, you just got to plug it into your calculator. I don't know what that's going to be. Let's see. I mean, you could have also divided this over here first. Maybe that would have been prettier. I don't know. It still sucks. Not gonna lie. Anyway, but you see how, because the power is stuck up top, I have to introduce logarithms, bring the powers down, and then I can solve for the x, because it's at the bottom now. That's the goal. That's what we're trying to do. Okay. Let me hit pause here. Okay. So sum of e to the x minus 6 equal to 11. So what I'm going to do, I'm going to cancel the e to introduce a base that matches the e. So remember we said ln is the same as base e. So on purpose, we'll introduce the logs on both sides. That will cancel this guy. Now I'm pretty much done. Let's just move the 6 over. So x will equal ln 11 plus 6. So you'll punch this into your calculator and you're going to get 8.4. Okay. Next one's a little harder. Maybe a little more algebra intensive. So for x, oh, you get 11 to the x plus 3 equal to 12 to the negative 7x. So again, I'm going to introduce any log that I choose, but I'm going to choose the ones that are on the calculator because you got to be able to punch them in. So I'm going to punch in, or I'm going to choose ln again on both sides. Now I need to bring the powers down on purpose. Bring down the power, bring down the power. I'm going to multiply the ln on both because I need to get all the x's on one side and I can't just do a quick division. So distribute this ln 11, so x times ln, 3 times the ln. This guy's just there as a coefficient. Now I'm going to move this one over here and subtract that guy over there. To just subtract this on both sides, add this on both sides. That gets us to here. Now this both has an x, so I can factor. So we're almost done with this one. We'll factor the x out. That'd be ln 11 plus 7 ln 12. This is just some number. This is like 2.7 or 2.7x. So in order to get rid of the number in front of the x, you divide both sides by that number, right? So divide both sides by this garbage. Dividing ln 11 plus 7, 11, 12 on both sides, right? So this is gone. So x is equal to whatever this is. So that's just punch this into your calculator thing, and we're done with it. So that is approximately this number. Okay, so this next one, I'm going to go through the solution. It's the same thing we just did, it's just different numbers. But check this out. So I need to get these numbers down, these powers, because there's x's in there. Can't solve for x unless you're at the bottom. So you can choose to bring in base e, which is the ln that I've been doing, or you could choose base 10, which is just the log without the number. Doesn't matter. I'll do e just because that's what we've been doing. So we start by introducing ln on both sides. We bring this down in front, bring this down in front, right? Then we distribute this on both. That gets us these two terms. Now we need all the stuff with x's on one side. So they move this one over here by subtraction. And this one just hangs out by itself. Now they're going to factor the x out like I did earlier. They pull the x out, and then they divide this stuff on both sides. That's how you get this. So this ends up canceling, leaving you with just the x, and then you punch this into your calculator. That's all we're doing. Well, actually, in this case, they leave it as exact because they said at the beginning. I didn't read that. Write the exact answer using either base 10 or base E. So they're making us use one or the other. If you use base E, you're going to get this, and that'll be your answer. That's number 12. Okay. Let me see if there's any more worth doing. By the way, Tiara, do you have the example button on your end? I forget. Like for your homework.
The example?
Yeah, you know how you press that button and it shows example like the example or during a question?
Oh, yeah, it's the one on like the right hand side.
Yeah, you have that right.
Yes, I do.
Okay, just making sure. Okay, then I guess we'll let me see if there's any. Let me check one more. Let's do one more and then we'll call it a night. What number is this? 15, I think. So 3e to the 3m minus 2, oops, minus a 4 equals to 11. All right. So before you do any kind of ln nonsense, you're gonna want to isolate the exponential. Okay, make sure our recording's on. Okay. So I'm gonna add that 4 over. That gets us to 15. Then divide both sides by 3. That gets us to my e. Then introduce ln on both sides so I can cancel the e. So now we're going to have 3m minus 2 equal to ln 5. Add the 2 over. Divide by 3. And that'll be our answer. This will be the exact answer here. Now you plunge that into your calculator, you're going to get 1.2031. So if on this question, they asked for the exact and the approximation. Does that make sense? Okay. Alrighty. Well, we'll stop here. Thanks for staying a little longer. And I'll post these as soon as they finish loading.